Problem number 7. I don't know what kind of name that is, but Varney drops a ball from the edge of a bridge over a stream. She sees it hit the water 1.2 seconds later. What are two different factors she can figure out with that information? Alright, not only are we going to say what those factors are, but we're actually going to find them. Once again, first step, write down everything you know. So, first thing, it's very obvious. They tell us that the time in the air is 1.2 seconds. So for this problem, delta t is equal to 1.2. Okay, now we have to think about the things that we know that aren't explicitly in the problem. The first being the obvious one. We're on Earth, so gravity is negative 9.8 meters per second squared. That's a 2. Okay, the next being that it said that she dropped the ball from the edge of the stream. And I've said it a lot of times, anytime something is dropped, or it says something fell, it means it wasn't thrown down, it was just dropped. It has a starting speed, or velocity initial, of 0. Okay, that's the information that we know by reading this problem. They're asking us, what else can we figure out? So out of all these symbols that we have, what else could we find about that ball that she dropped? Okay, the first thing that we look at, I think easiest one to start with, is if we can find out how fast that ball got. So one of the factors we can find is VF. We can solve and see what that is. So let's do that first. In the space here, we're going to use equation number 1, because so far we're not dealing with height. We're going to use equation number 1 to find the speed of that ball. So equation number 1 says VF is equal to VI plus acceleration times time. We know what all three of those are. VI, we just said, was 0, plus acceleration is the negative 9.8, multiplied by the time it was in the air, which is 1.2. So that ended up being a pretty easy problem. All we have to do is take 9.8 and multiply it by 1.2. Okay, make sure that you know it's a negative times a positive. So your final answer will be negative. Negative 11.76. That's the speed it reaches right before it hits the water. Make sure you have a label on that. It's a speed, so meters per second is the correct label. Okay, that was one of the factors we could figure out. The other part that we don't have, if you look over here, the only symbol we don't know is height. So in green here, I'm going to put how we can figure out how far that ball dropped, delta y. Delta y, ooh, it's a bad y. What is that going to equal? If you look up here, we could use equation number 3. Equation number 2, I think, will be a little easier because it already has delta y by itself on that side of the equation. The rest of the equation is what we have to figure out. Before we write that long equation down, let's look at this. Since we know VI is equal to 0, we're plugging that in for the VI here. If that is 0, it doesn't matter how much time it fell, that side of the equation is just going to drop out and go away. So when I write down equation number 2, I'm only going to write down this right side of the equation. Delta y is equal to 1/2 our acceleration multiplied by the time, t, but we have to square that value. Now we can plug in our numbers. So the height will equal 1/2. Instead of 1/2, I'm going to put 0.5 times our acceleration, which is still due to gravity, negative 9.8, multiplied by the time it's in the air, which hasn't really changed. It's that 1.2 seconds. However, we have to square that. Okay, all that's left is to plug that into the calculator. This one I'm not giving you the final answer on. You can do the math. I will remind you, the first step is you have to square that 1.2. So make sure you square that first, then multiply that all out. Your final answer, remember, will be a negative because it fell.